publication, always they ask what is the novelty you have. Novelty should be in terms of methods, in terms of its formulation, and the new, what is the new things you have. Okay, that's why just glimpses I am giving. As already I have told, I am not expert of graph theory, but I studied a little bit graph theory which is useful for me, and I am applying it. Okay, fine. So even in computer science we can use, these are some clicks. See, first one, 0 click, it is a point, no, 0 click. And here 2 clicks, AB, AC and BC, these are the click points, clicks. And even the third, 3 1 click, ABC, and 1 3 clicks, full ABC I have considered. Okay, next. Go for next. This is the thing. Okay. So let G be a simple graph, a polynomial. I am considering a polynomial G with X is called a click polynomial, and it is defined by like this. So ek x to the power of k, and polynomial always will be 1 plus x plus a naught x square. It will be like this, just similar to a standard polynomial expression. Next. See, now I have represented a click polynomial with gamma, and this is the thing. So E naught of zeta always 1, denoting the total distinct. It is a total distinct, and clicks in the graph size is k, and equation has the following properties. This equation 1 I have considered, I have expressed in terms of a click polynomial. Now this it should follows this property. Next. This see, E naught is 1 for all the graphs. This is a standard notation, E naught. And Ek is greater than 0. Whenever you consider clicks, it's always greater than 0 for all the graphs. And click polynomial at 0 is always 1. And you see, a complete graph with 4 vertices I have considered. And here later I can click with 0, 1, 2, 3. Next you go. You remember this graph? You see, with 0 clicks, we have only 1 Ek. With 1 click, we have 4. Go back. See, with 1 click means 1, 2, 3, 4. Got my point? With 2 clicks means 1, 3, 3, 4, 4, 2, 2, 1, 1, 4, 2, 3. Got my point? Are you getting? Okay, go to the next. See, with 2 clicks, we have 6. With 3 clicks, we have 4 Ek. And with 4 clicks, we have only 1. 1, 2, 3, 4. One complete graph. Okay? So, with respect to that, gamma, that is a click polynomial, you observe, this is for first one, 1 plus 4 zeta. Zeta I have considered as a click polynomial function, variable. So, and similarly for 2 clicks, it will be 1 plus 4 plus 6. Just like 1 plus a naught x plus a1 x square, like that. It is a common polynomial. So required polynomial will be for particular graph. I am using for the particular graph. You see the equation 2, and equation 3 is the generalization of that. Okay. So I have expressed a polynomial 1 plus 4 zeta, zeta square, again 4 click, and finally 1 click. Now you got an idea about a click polynomial. I will go for the boundary value problems. I am considering a boundary value problems. Okay. So this is the equation 4 is the boundary value problem. In general I have considered, and with boundary condition, equation 5 is the boundary condition. And you click polynomial, higher order derivative I required, because polynomial only we should consider as higher order derivative, and g of eta, g of n of zeta, n is represents its derivative. 1 means first derivative, like that. Okay. So 4 is the given problem, general problem I have considered, and equation 5 is the boundary condition, and equation 6 is the general form in terms of its derivative. See, now integrate equation 6 from 0 to zeta, g of n is there. I have integrated once, so it becomes n minus 1 types of derivative, and we will get like this. Using boundary condition in the above equation, I will get equation 7. I have used previous boundary condition to that, I have incorporated, and I will get equation 7, and proceeding in a similar n minus 1, because I am explaining in general, but it is a second order, no need to go for this much of steps. So go for next. So you have to see here, because this thing I have explained 1 week for the as a workshop. Whole thing I am incorporating in a one slide. I took 7 days to explain all this concept. I am explaining in 1 hour. That's why I don't require all the things. You see, fine. See now, in a similar fashion I am doing integration. Now I got equation 8 in a general form. There is a general form of the integration 8. Now zeta I, this collocation points, we require a collocation points and it is given by equation this zeta I 2i minus 1 by 2n. This is a general form and depends on your differential equation, we can substitute, you can use it. Yes, next. Okay, fine, go for previous slides. No, previous. Yes, leave it. So, these are the basic concepts you require to use a clique polynomial. So, you require a simple concept of a graph, different type of graphs along with cliques. How many cliques will be there for each point? It is sufficient. Okay, let's go. So, these are the some of the numerical analytical techniques they used to solve a solid mechanics problem. I am using solid mechanics problem. Okay. So, these are the method. Even we used some 7 to 8 different method, least square approximation method, 3-4 different type of differential transformation method we applied, collocation method we applied, and even ANN pin problem and even many numerical methods we applied. Okay, fine. So, this is the problem. It is solved and we applied alpha parameterized differential transformation method to solve this problem. And this problem which was published in 22, I will solve now using different methods. Okay. Modeling and formulation, this is all I think many of you may struggle to understand. This is a research problem. Okay, this is actually a pin. This is actually a pin. You know, pin means 1 or 2 sentences I will explain. I will not go in depth. So, extended part of the body. You may be well aware of a choke system in 100cc bike and 350 bullet bike. So, this will be very big in bullet. It's all because heat transfer, production rate will be more. Okay. So, heat production will be more, therefore, they required this type of extended part. Okay. So, because of color, okay, one problem. So, this type of extended part, you may not be knowing this, we required. So, pin means extended part of the body. It may be used for heating as well as cooling depending on the situation. And here we have different type of pin structures. Pin, a dry pin, wet fin, fully immersed fin, partially immersed fin, partially wet fin. Like that, depends on the physical situation, we use different type of pin structures. So, in this present situation, in this present situation, we have immersed with some nano lubricants. We used a nano lubricants here. Yes, next. So, this is the mathematical equation. You observe it is a second order equation. You observe this, it is a equation 1, it is a second order ordinary differential equation. Not much complicated differential equation, and even some of the cases, if you consider general case, you can get an exact solution very easily. I have imposed some condition, that's why this nonlinearity has come. Maybe looks different for you, but it can be solved very easily. If you not imposed any conditions. Okay, these are the coefficients of internal heat generation, the condition which I imposed. And these are the non-dimensional terms, what Giri sir earlier told. Non-dimensional can be done in 2 ways. One is in many ways. One simple way is by using similarity method. Another one is in beginning itself we will make non-dimensionalization, then we will get a parameters. So, this is the non-dimensional equation 4. Now, this is the equation we need to solve. Equation number 4 with the conditions 5 need to solve, and you observe this is second order ordinary equation and simple, not much non-linearity has come here. Next. So, these are the thermophysical properties. Again, it is a research problem and it is in ready-made data. Now, we will by using, now I will solve this problem by clique polynomial. You see the differential equation number 6 with the condition 7. This is I am going to solve. And now actual data starts. See, here we have second order equation with respect to theta. For that only I have to approximate a polynomial. So approximate second order theta double dash using the clique polynomial given by equation 8. I am approximating with that. I have given, while explaining a basic concept, I have given g to the power of n. That data only I am using now for the second order. So here gamma, capital gamma is the clique polynomial function. Yes, thanks. See, equation 8, the previous equation, anyhow my intention is to get theta. So go to previous thing. Yes, you see equation number 6, you see, this is a second order differential equation with theta, and solution what we required, theta. Theta, I want a expression for theta, whether it is numerically or articularly, that doesn't matter. I want theta. Okay. So this problem we solved by differential transformation method. Now I will explain clique polynomial method. Okay. So previous equation 8, which we approximated for the second derivative. Now I have to get theta. I have integrated 2 times and I got equation number 10. Equation number 10 I got after integrating the approximated polynomial 2 times. Now theta of 0 is equal to 1. These are all the conditions which we initialized, and I will get equation number 11. And substituting and after calculating, you see I will get this polynomial. So I got this polynomial. And all of you know, even PG students, you know, whenever we get a polynomial solution, we will not consider as a exact. It's a semi-analytical. And even we cannot validate, we cannot accept as an exact solution or even near to exact, because we don't know its condition of convergency. If it is not convergent polynomial, then how to believe that solution is correct? So these are all faculties are associated with this polynomial solution. And whatsoever it be, even whenever we solved a problems with a differential transformation technique, particularly the reviewers raise the question, the same question, how you believe that this is convergent for particularly this value? Okay, I consider only 5 points. Similarly, I can consider many points. But why you consider only this point? This is the technique. This is the problem always arises when you go for a polynomial solution. But as already told, we know how to judge the convergence of a polynomial with the aid of paid approximate. By using that, easily you can do it. But of course, this is one of the challenging case whenever you consider a polynomial solution. So this is the polynomial I got, equation 12. Next. 13, 14 and 15 are the different polynomials that I got by putting the values. Solving the equation yields the values of coefficient EI. Okay, this is the UC, theta. Final solution of theta is given by up to x to the power of 6 I have extracted. But even more than that you can get it. You see the coefficient of x to the power of 6, it is almost negligible. Means x to the power of 6, whenever give the value for x to the power of 6 times, it will be the form of fractions. That's why I have stopped at x to the power of 6. But by using paid approximate, applying paid approximate also, we can ensure the solution. Okay, next. So this is the solution. This is the previous case. This is the solution of the theta. Previous case is the solution of given problem by using clique polynomial, and I have compared. Okay. So first one is clique polynomial method. So RKF, Runge-Kutta-Fehlberg method. This is a very known numerical method, and we can believe this method under certain conditions. I compared, and you see the error. So this RKF method can be believed, and in some particular cases, of course, in place of RKF method, you can use exact solution method also. But I have compared with RKF, and you can see the absolute error is 10 to the power minus 5. So for this particular problem, and I tell you honestly, it is not applicable for all the problems. There is so many practical difficulties also will come. You have to use again and again particularly the paid approximant, so that to get a convergent solution. That difficulty is always there with this. Yes. So you can see that in most of the cases, our click polynomial method goes along with the numerical method. Okay, go for next. So click polynomial method, just I wanted to introduce, and many concept even I have to understand now, because my students are good in doing a polynomial solution with a paid approximant we are doing. But again, I have to go in depth of click polynomial. If some of you know other than this click, definitely we can do wonders with the solution methodology. So now I will go for the physics informed neural network. Same problem I have considered. Not a different problem, the same problem which we published. Okay, so equation 1 and 2 is the boundary conditions. What about next? Next. 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 See now. This is the thing. No, I think the first graph. This is what we called as a calculating domain. Okay. So x1, this is the input methodology. So zeta, zeta 1. Here I have taken x1 instead of x1, x2. I have taken zeta to make maintain the same notation. So zeta I have taken input, and here two types of neural networks are there: forward as well as back propagated. Here I am using I am not using ANN, that original ANN. I am using pin. So here you see the third one, d by dx, d square by dx square. This is the loss function with respect to derivatives, and I d by dx, that is a loss function with respect to initial conditions. And those loss functions also I have generated, and if loss function is minimized, I mean we got in desired accuracy, I will get a output. Okay, this is what the things happens. And here the loss functions, this is in hidden layer, we cannot see that, only we can see what are the input I am giving and output. Hidden calculation layer we cannot see, that's why we say it is an hidden layer. Go for next. See, the same problem I have compared with PIN and RKF, and you can see that it also coincides with this. Okay, let's go for next. So this is the thing with respect to PIN and learning rate, epochs, layers. These all will come. We have to choose number of layers also. Sometimes we choose 3 layer structure, 4 layer structure, and network and epochs. Epochs also plays an important role, particularly in choosing a loss function. Yes, next. So comparison of PIN results with RKF method, and again you can see almost 10 to the power minus 5 accuracy we are getting. Okay, fine. The next things are with respect to the research related. So okay, that I am not going to touch. I have introduced a click polynomial for the solid mechanics problems, but my colleagues, they solved the same, applied a click polynomial method to solve a fluid problems, the simple fluid problems they solved, and many problems are open. You can solve it by using click, and also as I already told, my colleague told that many polynomial solution methods are there in the graph theory. So if you know some methods, definitely we can do it. Okay, and for the students, as you know, there is no alternative now, as of now, for the artificial intelligence. You have to learn it, and it is easy also. So by using, even I am using MATLAB and Maple for the sake of solving the solution, but when compared to these two, even of course artificial intelligence I am using with respect to MATLAB itself. But when I compared my earlier numerical techniques to solve the problems and this ANN or even PIN, I am getting very easy. Okay, so it is an open problem. All of you can try because even Python is also there. By using Python also you can frame these neural networks problems. You can study it very effectively. But I don't know exactly how the people are doing. But in MATLAB it is very easy. It is an inbuilt function. Okay. So this is what I want to explain. So if you have any doubts, now the session is open, we will discuss. Student side, if you have any doubts, if you want any more clarification on this data, I am ready to explain.
Sir, you compare the PIN and K4 method.
Yes.
What technique you use to get that error, sir? It means in hidden layer we can't see the cost function how working. You said that,
Yes,
sir.
yes,
In ANN dependent means depend on data.
Yes.
How we get given data, get the corresponding output.
Yes.
You said here have the independently we can take the problem.
I
and
got
that's we can,
your point, madam. You are asking about how
cost
you are
function.
comparing with your data with the ANN, right?
Yes.
With RKF. Okay,
Yes.
fine, please. So we got input data here from the exact method. We trained our this simple problem. For this simple problem, exact method is applicable, is available. We have taken the input data and we trained. So and we compared with the RKF. Even RKF almost gives the exact when the problem is simple. For this particular cases, there is no problem. But when you, yes, of course, I understood what your question is. But when you go for little complicated coupled, then your input data and training data, validation data is definitely a challenging one.
For example, sir, higher order.
Yeah, I got it.
Non-linear higher
Yes.
order taken means how to make that.
Yeah, the only option is you have to believe, first you have to ensure that your numerical code is correct. Your numerical code, because you are comparing your data with a numerical, what you are doing, yes, I hope all of you got it. So it has 3 stages. One is training and validation output. If you are doing training and validation with the same method, then the question is how to believe. Am I right? So here, if you are doing training with RKF method, validation is also RKF method, then of course whatever you give it, you will give output and exactly 100% is matches. For that, you have to ensure, but actually you have to use 2 different methods. Input data should be, if it is from RKF, validation should be done with the exact. But particular cases, we can do one thing. We can minimize our equation by putting, neglecting the additional conditions. Make sure that there is an exact data and you list out the values. For the same data, you take numerical values, validate, and you see that both are matches. Then you go for the next one, next higher order one.
For minimizing purpose, what you using? I am asking.
See, minimization for this particular example, it's a second order ordinary differential equation with 3 terms. Exact is available. Exact is available. I have neglected the additional conditions. That's enough. That's all. I have not done anything extra. Additional conditions I have neglected. Then I got exact solution for this differential equation. I have verified. But for the higher order, you have to take care about the input data, validation data. Okay? Yes.
Thank you, sir.
Any other question?
Yes, yes, tell me. For you are telling ANN, madam. So
Pin.
Pin you can apply, madam.
I can apply.
Pin you can apply. ANN we struggled. Even for the 2 layers also we can struggle. But pin you can apply because it understands physics itself. So even I applied that method for the 2-layer problems. I think it is in, and I have not completed, but you can apply it. You can apply it. Pin you can apply, but I am not sure ANN because lot of thousands of input data itself required, and even ensuring the validation is also very difficult. But pin definitely you can believe, you can apply, madam. I am sure.
Thank you, sir.
Sir, while using the graph theory polynomial or any polynomial, I think it is very important that that polynomial have all the terms. No, sir,
yes,
like
yes.
1, x, x square, because there are many polynomials which are maybe only even terms are there, or some polynomial have only even power, or some polynomial have only odd powers. So such polynomials, I think we cannot use.
Madam, that's why I am telling. See, I have very less knowledge in graph theory. But when you give a polynomial, but easily I will ensure whether the answer is correct or not. Suppose you are giving even, but I am not sure and whether that is okay for my present problem. But if you give a idea of that even polynomial, I will apply for my one simple problems and I can verify easily. And later we can extend for the complicated one. Because I am not sure whether, but for this clique polynomial it's a very primitive, and of course it contains all the terms. But I think that, I am not sure, but if you give that type of polynomial, I will check it.
I have tried with that one, like where only even terms are there, only odd terms are there.
Okay, okay.
Like when we do the inverse, like
Okay.
it comes because we have, suppose you are taking clique polynomial, each term has to be represented in terms
Yes,
of, each derivative has to be represented in terms of clique polynomial.
Yes, madam. Yes,
So that means suppose if it is x square, derivative will be 2x, but x is not there in the polynomial.
Okay, madam.
Then it will be problem.
Yes, okay.
Yeah.
So I am not sure.
Yes, sir.
You give me the data, means the polynomial, I will check it.
Yes.
And
I have used this one complete bipartite graph polynomial. It works very good, sir.
Okay, that I will.
Maybe you
then I
can
try.
also.
Yeah, that's what I'm
use
telling.
Your neural
So,
network.
my intention, even I am not good in graph theory, why I introduced here many people will come. So, particularly the graph people, if you give an input, it is an added advantage for me, it is more beneficial for me. Because I don't know what are the type of polynomial. It takes a lot of time for me. So, you are, as a graph theory expert, you said one word and I catched it, and tomorrow I will tell my students, do it, work out it.
No graph theory, but I have used the polynomial.
Okay, you
like
also
you.
not graph. Okay,
No,
fine,
no.
fine, okay, fine.
Yeah, I also use the polynomial.
Oh, sorry, okay, madam. So if you, if any of you are in graph theory and you know the different type of polynomials, so it will be helpful for me. Okay, thank you, madam.
So I want to add to Madam
okay.
question.
Yes.
So if you increase number of layers,
Yes.
there is no much gain in solving the differential equations, because universal approximation theorem says that a single layer is enough to produce any kind of continuous function.
Okay.
So if you add layers, nothing is gained. Okay, maybe some
Or
points,
some points maybe.
but that not considerable. Universal approximation theorem says that a continuous function of n variable can be reproduced with n into 2n into n plus 1 neurons. Okay. Okay, there is, but we have to ensure in pin. Okay, thank you.
So, means, madam, of course you are doing 2 layer, 3 layer, only to explain the novelty. But I think maybe, sir, because there no much difference, but today I came to know. This theorem I am not aware of it, I have applied, but very less minute changes, improvement in the quality. Yes, again we will throw it. So of course, now I got it, madam. So we applied 2 layer, 3 layer. But as sir told, there is a very little improvement. But for me as a mathematician, little is enough. And I have told, I have applied 3 layer and I got this. But as sir told, maybe I will check it, sir. I will check it. Because I am not aware of that. Okay, sir. Okay. Okay, sir. Oh, okay, sir. But for ANN we struggled, but PIN we applied 2 layers. Let me check it. Okay. So from student side, if any doubts are there, I can clarify. Thank you so much.
Thank you, sir, for a wonderful talk. So I would like to call upon Dr. Manjunath to hand over a memento as a token of gratitude.